What a way to start. What a way to start.
God bless.
Did I not hit the mute in time?
No, no, you just blew it all over the stream.
Yeah, in your screen too must look pretty nasty. You probably want to wipe it.
Oh man. Sorry, I'm allergic to all your bullshit. I'm sorry.
Ouch.
Well, we are live for the next Worm Fight Club. So on deck, we have 6 compounds ready to battle it out in the pump science arena. Up first, Benji, who do we have?
The one, the only Raptor. Let's fucking go. Welcome to the stage, ladies and gentlemen. We got both devs here. We got Ethan, we got Carlin bringing Raptor, the rapamycin and SMR28 combo, which apparently is just like God's gift to humanity, but you know, maybe they can tell us a little something about it.
Well, we just got off a stream with 2 autophagy experts, including the scientist who was a grad student when I was and part of the original discovery. So they dropped a lot of knowledge on that stream. Want to check that out? Anyone, all Rapamycin Longevity Lab, our friends, anyone who's a friend of autophagy should check out that recording. But yeah, we're psyched to test the combination of rapamycin plus SMR28 autophagy boosting for the win, baby.
Let's go. All right, guys. Well, I guess, what did you learn during that stream?
Carlin, you want to drop some alpha?
I learned quite a bit.
Carlin said he learned quite a bit, but like, were you like schooled or I don't know?
No,
humbled?
It was well, it's humbling to think about all the science that breakthrough science that we're all doing on pump science, but especially on the autophagy side, it's a frontier. So yeah, no, there's just super, we talk through the performance enhancing implications, the rare disease implications, all that good stuff. But
the upstream, the downstream, different pathways we can hit. Yeah, it was great.
Feeling good. I'm feeling good.
Let's get the right orientation in this. B.
Here we go.
Here we go. The worms are cruising. None are dead yet.
So what exactly are we looking at here?
Yeah, tell us, Pump Father.
Boys are killing. Absolutely. So basically what you're looking at here are all the different worms that are being tested for Raptor versus control. So 67 worms got Raptor. At this dose, we have a bunch of different dosages that were tested. So this one's cruising along as well. This is a different dosage of Raptor. 4 being tested. We're keeping them hidden though, just because like we want to keep the IP in case that Raptor wants to patent the dosages around the different combos. And yeah, so like we got 4 different dosages being tested. They wanted to make sure that they got the right dose. And so what you're seeing at the bottom here are the different replicates. So basically like Raptors tested in I think like 3 or 4 different replicates as of the control. And so these are all the worms in each of the different 2 replicates.
I'm looking at
3 replicates for 5. Yeah, 5.
You can actually track the health of each individual worm.
Exactly.
Which one's your favorite?
Someone's trying to see which one will.
Who's the favorite?
Whichever one does best.
Yeah.
Yeah, which one? Yeah. How do we tell what the hell happened?
I mean, you can tell in real time.
It's looking good so far.
It's looking good so far. It's
well, I'm like
life extension.
I'm like watching you. I'm like, I could get on the page too, but I'm like watching you. Wait, don't we want to play to the end?
Well, I'm just trying to follow which.
Oh, I see. Gotcha. Which group does the best?
Which curve looks best? Well, it's all happening in real time.
Mm-hmm. Okay. Cool.
So this is only at like release number 92.
Okay, so
Jillian, the beats are kind of a lot.
Are they a lot? Let's kill him. Ah,
so
I
we're
think maybe we could do some chiller music, some more better background music. But Animals by Martin Garrix is kind of a
it
lot.
just went to the next one. It felt right. I mean, we are looking at animals.
That's right.
wait. I'm impatient. How do we get to the end?
Oh, you want it faster?
I want to know what the hell happened. I'm like, this is great seeing all this, but where's the final data?
Exactly. What is the result?
No, we got to see the process a little bit. That's what's fun for the
Alright.
traders.
The sausage is being made. Okay.
The traders like that. For us scientists, we really just care about the result. But you know, when you're in Web3, you want to see how the sausage is made.
The drama. We need a little drama.
Wait, they want to see our sausages? What?
Yep.
It's not that kind of stream, guys.
I mean, we are talking about worms.
All right.
Okay, we got some separation there in one of these groups. That looks good.
Yeah. This one looks pretty solid. So
Nice.
it's hidden what all the different doses are. So I can't tell you which dose this one is. But this one
We'll
got
figure
11% life extension.
Sweet.
Okay, but we wanted to get at least
Figure
rapamycin alone.
Yep.
This one is still streaming. Oops.
So with Raptor, how many
This
doses
one we
were
got
there?
some
3?
separation too.
We did 4 doses. I think.
There were 4
Four
doses.
doses.
This one
For
doesn't seem to be as
Raptor,
good as the previous one.
Sorry, you tried 4 different doses, changing the doses of both compounds or only one?
Correct. Yeah, a high and a low of each.
Okay, this is nice.
This one not start yet. All right, we'll come back to that one.
It's fun to follow along in the
It's
chat
still ongoing.
too. The Telegram chat.
Yeah, that blew up.
What are the vibes?
The vibes.
Vibe check.
Oh yeah, with all the updates.
Yeah.
Mhm.
There's so many.
Yeah, just
Is it exploding?
it got crazy in there.
Oh yeah. Just with the play-by-play of all the experiment summaries.
It got crazy in there.
Mm-hmm.
Yeah, just the auto-generated summaries.
Is it doing?
Uh-oh.
Let's see what's going on here. This one seems to be a bit crazy.
Mm.
All right, so that's not the right dose. Whatever
That one not
was.
looking good. Yeah.
Nope. 4 shots.
That's probably.
roll.
You
Oh,
know,
wow.
I'll predict that's high.
It is going ballistic in the channel.
Yeah.
Yeah.
4 experiments at once, I guess, is tough.
Oh,
Yeah, I
goodness.
can't say we've done that one before.
Raptors pushing the limits of what pump science can do. You're welcome.
Straight up, straight up.
Oh boy, oh boy.
Holy shit!
It really
is
does, like-
exploding.
Yeah, it is.
Oh my god, that shit is crazy.
I think, yeah, it looks like 2 of the dose groups might have been not optimal, but looks like
That
at
one
least
looks
one
done.
consistent.
I would like to know, because in the last 2 graphs, I saw extension in the maximum lifespan. This could be interesting. Only at the end. Because when you extend the lifespan at the beginning, can be many diseases, but at the end could be aging. So this, I saw it a couple of times there in your graph.
Mm-hmm.
There is a shit ton of data. There's a lot of data here.
All right, it looks like whatever this dose was the best. 11.2%. Are you seeing a better one?
I'm not sure.
Yeah, this one's getting about 10%.
Okay.
So far. I think it's
10,
done.
11.
There's a lot of data here.
Okay.
Yeah. All right.
So not yet king of the pill.
Not of the worms, but doesn't mean
Not
it's
of the
not
worms.
for
Yeah.
one of the other animals. Okay. I think this is the number.
That was the best of the 4.
I
Okay.
think that was the best of the 4. Let me see if anything else updates. I think they're done.
The data speaks.
All right. Well,
And we listen.
that's why we take multiple shots on goal in each model, and we have multiple models.
Mm-hmm.
Indeed. Okay, so this one didn't do much. That dosage.
Yeah.
No. Okay.
18.
And worms
This
can be funky.
one- worms can be funky. This one didn't work.
I mean, just like we saw
This-
with Riff and Euro, it doesn't. They don't always correlate between worm and fly, let alone with mice.
100%. 100%.
Yeah.
But it looks like what I'm super interested to see what these 2 doses were, because this one got 5.6 and the other one got 11.2.
Interesting.
Yeah.
Okay.
Mm.
All right, we got learnings here.
Yeah, exactly. There's
I think
no matter what the
learnings.
result, we can take something away. So that's a win for Raptor.
Hell yeah. Yeah.
Curious.
It's like this one was almost exact half the effect as this one, which is super.
That's true, but RAP alone should have been 30 something. So clearly, at least in worm, maybe combining them, it's not so obvious how you do that.
Great, yeah.
Or maybe it's for worm reasons, it could be. Yeah, there's actually data about the target of SMER28 in worms where there's evidence showing activating it could extend lifespan, but knocking it out could also extend lifespan. So it is what it is.
You haven't tried. You haven't tried the SMER28 alone, right?
No. I mean, we should probably, we have the money to do it, but that I'm not sure that would be worth it at this point. I don't want to get stuck in worms.
Yeah,
Worms
absolutely
could end up being very worm specific. I say that because of our performance. If we were kicking ass, I'd say worms fucking rule.
Yeah,
Fuck the worms.
We can see how the fly stuff shakes out too, and then maybe go from there.
The worms are just doing their thing.
Yep.
Let's see how everyone else is doing here.
They're a great model organism,
but not as good as mice.
Nowhere near as good.
All right. Well, now we're good. We're very sportsmanlike here, so we're rooting for the rest of our teammates here.
We just want to see OMIPAL toppled. That's really all we want.
No.
We like the changing of the guard, I think.
It's only a matter of time, I feel.
But Girish, as I said in one future stream, you are the worm guy. All the results doesn't work in worms, but it can work in other species. Why is that the case?
100%. I mean, like, there's many different reasons, but like as Ethan mentioned, there's very worm-specific biology at play a lot of the times. I mean, for instance, you know, there are these 12 hallmarks of aging that are characterized. These are like the driving forces, or these are the characteristics of you know, biological aging. Some of them even have causative roles in driving, you know, age-related disease. But in worms, for instance, telomeres have a very small role to play, telomere shortening, right? Same thing with, you know, inflammatory signaling, dysbiosis. So there's certain hallmarks that are very, very important, as it seems, for mammals, but for worms are relatively insignificant. Interestingly, autophagy does have a significant role to play in worm biology, but like that's just one factor, right? In this like enmeshed network of interactions that's driving the biological aging process. So I think what we could be seeing here, and what we've seen several times, I worked for the C. elegans intervention testing program, is, you know, what we did was we would run these experiments with metformin and rapamycin and, you know, SGLT2 inhibitors. And many of the times we'd see results that were like not inspiring at all in worms, like anywhere between no effect to 4 to 5% effect. And then in mice, it would completely explode, right? You'd see big life effects. So I think that really probably in large part comes down to species specific mechanisms at play. But yeah, that's just like one slice of the pie, right? That's a hypothesis. So super interested to see how these play out, how the results play out in flies. And
one thing I'm also thinking about it, and can you check the controls lifespan, median lifespan? How long did because it can in some cases be that the controls live super long. So that can be also interesting to check out.
Yeah, I think at first glance it looked like they were 18 or 19 days. So I don't think that's it.
No, that seems normal. Yeah.
Yeah, and there's so many other factors, right? Sorry, I was just going to say, like, whether the worms are fed live bacteria or dead bacteria, how the different reagents mix together, like on a chemical level, on a chemistry level, that can affect, you know, how the drugs are absorbed on the plates and how the worms interact with them. So, you know, I think it's just like I think I heard you say this before, Paras. The environment that the organism is on has a big effect on lifespan, right? So these worms are kind of crawling around on agar plates and, you know, eating their drugs with their food, and the mice are going to be in a completely different environment with a very different context. So anyway, I think it's just important to take in, like, absorb that complexity when interpreting these results as well, and also admire that rapamycin alone has been replicated across, you know, so many different species and so many different labs. Like, when you see that, there's something special there. So, you know, I still think that there's a there with this conversation. So excited to see what the future results will be.
Yeah, same. All right, what's going on with ASTAX now?
I'm checking out the token. Doesn't seem to be doing a whole lot. We got a solid $5 in volume, so a lot of activity. But
all it takes is one mention.
Hey, we saw that yesterday.
Yeah,
so true.
That was,
you know,
crazy.
We could have been streaming 11/11. Just saying.
all right. The devs were busy.
Tell the devs.
Take it up with the devs.
Do we have the dev here, or
They remain anonymous.
Yes, they are.
For this
they're
compound?
very quiet. Yeah, they're very quiet. They slid
but
into the Twitter DMs.
who is crypto? I don't see what the
Crypto
name is.
RuMD. That's Dr. Eric.
Okay.
So how far along are we through this experiment, Benji?
We're just over halfway. Let's see how many of the animals are. We got like 50% of the controls alive, 60% of the astaxanthin worms alive. So this one definitely looks like it's having a solid effect. Nothing too crazy.
Let's go. So just for folks who are tuning in, wondering what on earth they're watching, what we have done is done worm experiments in C. elegans, and it's about a month-long experiment. And what we've done is taken the experimental results from that and compressed it into I think it's a 15-minute replay now, Benji, is that right? A 15-minute replay, and are streaming the results to you for the first time here live. So that is how you are able to see this experiment that normally takes about a month in 15 minutes, which I know Ethan said he wanted it faster, but that's pretty dang fast.
No, I'm not complaining. It was really fast.
He likes it fast. Yeah.
Condense it even more, and let's get some TikToks going of the
Oh, man.
of the data going, right?
Yeah. But But Paras, what is this type of compound? I know they have tested this in the ITP and got some interesting effects.
Yeah, as antacid reduce a bit of the body weight of the mice, but only in males, and sterilized sperm only in males. I do remember, and it's very interesting. No, it's not very huge different, but I think that it's touching something metabolic. It's a natural compound. I remember. I think so.
Seafood. It's found in. It's pretty
Seems that
dense
all
in
the
seafood.
To me, I think that it's a very interesting compound to combine with something.
So do we have red worms and blue worms? I think Benji might be frozen. I'm not sure. Benji, can you hear us?
No, Benji is.
It's frozen.
Benji's frozen. Okay, hold on. Let me ping him.
Who is sharing the screen?
Benji.
He's processing a lot right
Benji.
now.
Oh.
He's going through a lot right now.
Let me see. Oh, wait, it's back. It's back.
Benji, you have to pay a better
Computer.
Wi-Fi.
Oh, wait, are you back, Benji?
Dude. My computer is not loving all the worms right now, I'll tell you that. There's too many worms for my computer.
I'm picturing, you know, that
Right.
like red pill, blue pill, like a red worm, blue worm. Red wormies.
Do they really change colors, or is that just like for fun?
I don't know. I want them to.
So they the blue dyes the bacteria. And I think because the worms eat the bacteria, I think they do change color a bit.
Cool.
You can go check out those pictures. All right. Astaxanthin looks like it works a little bit. It's no raptor, but
You damn right it isn't.
Yeah, well, raptors no OMIPAL, clearly,
Yeah.
at least in worms.
Yeah. I think astaxanthin showed a 12% lifespan extension in the intervention testing program in mice. So this could be an example of which you're getting kind of like a milder effect in worms for whatever reason.
Maybe for people who don't know, what is the ITP? Maybe share a little bit about that. We've mentioned it a couple of times.
Yeah. The intervention testing program is a government funded, right? NIH funded program focused, the first of its kind, on like gathering robust results on longevity enhancing compounds. And when I say robust, I really mean robust in the sense that all these labs can run all the experiments they want all across the world, but there's no like synergy, there's no control and standardization of protocols, of drugs. I mean, when I was part of the intervention testing program, we went down to the very temperature in which our microscopes and the types of lamps that we use to light up the plates where we were looking at the worms, so that we can control everything as much as we could down to the very T.
Wow.
And within the mouse intervention testing program, Richard Miller's kind of spearheading that. It's 3 different labs that are running the same lifespan experiments for a given compound. The compounds are nominated each year, and there's a advisory panel that will decide which ones are worth exploring. And a little caveat here: GLP-1 drugs still haven't been tested. There's several that haven't really been tested, but I think there are around 80 to 90 compounds that have actually gone through this program, and we might have had about a dozen hits of compounds that have actually extended lifespan across 3 labs with the same sort of breed of mice. And one of the compounds that extended lifespan the most across these labs was rapamycin. And interestingly, you also see some additive effects when you add rapamycin with metformin or rapamycin with acarbose. So yeah, it's an awesome effort. It's a very slow and grueling process. And there are definitely like strings attached in terms of what compounds can actually go through the intervention testing program. And that's why I think the Pump Science platform has its really unique and impactful place within the ecosystem, because it's like kind of we're able to run these robust experiments thanks to amazing partnerships, worm experiments with Aura Biomedical and mouse experiments with Paras and everything he's doing. So we're able to, kind of like open the field and test a large number of compounds, which we wouldn't be able to do with the intervention testing program. I think both have their place, but yeah, super interesting to see how like our results kind of parallel what we see with the intervention testing program itself.
And something very interesting that we differentiate from ITP is, for example, in the mice, ITP only measure lifespan and body weight in 2 or 3 time points during the whole life of the mice. We are going to do much more than that with measuring strength, activity, blood collection, frailty score. So we are going to have many more data, and that could be super interesting for many things. That maybe we are not going to extend lifespan with many compounds, but maybe we can see something that could be patentable, IP to create patent with something that we don't expect, that could be even more super interesting for all the intervention that the developer are launching in Pansai.
That's a super important point. Especially when you're thinking about like healthy longevity, right? I mean, for all intents and purposes, the organisms that you see a lifespan extension in do seem to have, their health intact as well towards the end. But it's super interesting to see, like, even if you don't see a huge median lifespan extension, if you're still delaying cancer and delaying cognitive decline, and those mice are fit till the very end, cognitively, then there's something very, very interesting there that within the ITP kind of gets lost, because the main primary metric and endpoint is, total or median lifespan extension. But with, Paras, what you're doing is we just get a lot more information to work with. So I think, yeah, it definitely like makes a better case for products entering the market as well, right?
Yeah, and to understand the mechanism of action of the compound. Because actually, the most of the mice die because of cancer. And for instance, let's imagine a therapy like chemotherapy could work and extend lifespan, but this doesn't mean that you are targeting aging or another diseases. So collecting a lot of data, we are going to get a lot of information.
And on top of that, Paras, you're doing it in a streamlined way and cost-effective way. So, yeah, big thumbs up for that.
Yeah, no, I was discussing with Benji and Gillian that always that we get something unexpected, an important result, and directly to create a breaking news or something, that to post it as soon as we have the result, and that the people try to even to guess what is happening, or say, come on, we don't expect that, it's good, and something that to create engagement and that the people are live, following the experiment all the time.
Yeah, for folks who missed it, we shared yesterday a video with some breaking news from the lab. So Paras called us up and shared some interesting findings that we were seeing, and want to do our best to keep that information coming to people as quickly as possible. So you'll be seeing more of that and getting people as close to the labs as we can. Benji, which compound is this? CBD?
Yes, ma'am.
Oh, no.
CBD does not look like it does too well. So hide your weed.
So
Oh, man.
maybe
The potheads are.
I don't know if the worms are
Happier.
happier, but no healthier.
More sedentary. Let's have a
Did
moment
they
of
move
silence
less? Yeah.
for CBD. Yeah. Oof.
I was going to say light one up, but not here.
Do we have THC launched as well? No?
Do we? No, one of the devs was about to launch THC and CBD, but instead launched something else.
That's what happens when you're on THC.
Had a different idea. Clearly had a different idea. But no, it's what it's. I don't want to say who it is, but it was one of the other devs.
I'm surprised the Cocaine Lab hasn't been launching more tokens than us.
They're busy. They got distracted.
Not
as
living
you
up to their
probably
name at
imagine.
all.
Who knows? We may be the cocaine dev team behind everything. Yeah.
Which one do we have next? Are we still looking at CBD here? Finishing up?
Yeah, CBD is still running. The next
Okay.
3 are docs.
All right, let's go rapamycin longevity lab.
All right.
Here
Oh,
we go.
boy.
What you gonna do? You got the shot.
Yeah. Girish, do you want to say something about the doxycycline?
Yeah, doxycycline's been around forever. It's been around, I think, since discovered in the 1940s or 50s, synthesized, and typically prescribed as an antibiotic for treating infectious diseases, bacterial infections. And what's really interesting about doxycycline is when you really dig into its mechanism of action, the way it kills bacteria might be the same way in which, or one of the ways in which, it's extending longevity. So it's been shown to bind and interfere with the protein making machinery of the bacteria, right? And proteins are the cellular machinery that do everything, right, for our cells, basically. And by doing that, it kills the bacteria. But in mammals, it's been shown to interfere ever so slightly with the protein making factories called the ribosomes of the mitochondria, right? And mitochondria are they're of bacterial origin. They're these ancient descendants of bacteria, which are, our cells have engulfed and formed this symbiotic relationship with, where we provide some protection to the mitochondria from external forces in the environment, and the mitochondria chews up our sugars and fats and turns it into cellular energy. So it's this beautiful, beautiful relationship. And, for sure, our survival and our longevity, there's a codependency there between our, the higher organism and the mitochondria within our cells. So doxycycline has been shown to have this hormetic effect, right? Where, hormesis is, you've heard the saying, what doesn't kill you makes you stronger. Hormesis is kind of like what doesn't kill you makes you live longer, in that it's kind of stresses out the cells so that the cells say, hey, there's something that's outside of my environment that's a threat. I need to become more resilient. I need to up my game. I need to fold proteins better. I need to repair DNA better for my own survival. So it's like this hormetic sort of response. That's one of the ways in which doxycycline could be having beneficial, healthy longevity effects on organisms. And indeed, in mouse studies, doxycycline has been shown to, slow aspects of aging, even in mice that have accelerated aging, this disease called progeria. And within clinical practice now, beyond its use as an antibiotic, it's been shown to have anti-inflammatory effects as well. So it's used in dermatology for, inflammatory skin conditions like rosacea, periodontal disease, which is like tooth decay, more or less, in which there's inflammation of gums, and that's a major driver of the tooth decay, and doxycycline seems to be pretty effective there. So it's kind of like popping up in different aspects of health span, oral health and skin health, and other aspects of health as well that we could talk about. But yeah, super interested to see how it affects lifespan in normative aging worms, right? In organisms without particular mutation or accelerated aging phenotypes. And previous research has highlighted that doxycycline can extend worm lifespan, and where moving it through the gauntlet, seeing how it's going to affect worms. And then, maybe we could talk more about some of our future endeavors that we have for doxycycline and unique applications. I don't want to let the cat out of the bag right away, but let's see what happens.
But on top of that, it's quite interesting that it's also a FDA-approved drug. So it has a good safety profile, and that way we can have a fast path to market, which is quite interesting to explore.
Yeah.
And doxycycline is a compound that we use in mice all the time because in many transgenic mice, they have the induction of the transgenesis and the induction of the overexpression of some genes. We use doxycycline for it. And always that we run experiment, we use animal only with doxycycline as a control because sometimes doxycycline alone show effects, so show a positive effect. So I agree that it's a very interesting compound. And I'm not sure. I didn't find experiment in mice that they treat only mice with doxycycline to see longevity. Indirectly, yes, but only for it, maybe not.
I know ITP have tested, I think it was minocycline or something like that, which is a little bit similar to doxycycline, but doxycycline is a little bit more powerful than that. So super interesting sharing there around mice experiments for us.
All right. I think we got our answer for CBD.
What are we
She's
looking
not
at?
pretty.
Ooh,
That is not good, no?
no.
It's not good.
It's not going to deter anyone. Quality
I
of
don't
life.
think so. As long as they know what they're
Quality of
getting
life
themselves
benefits.
into. As long as they know what they're doing.
But how is it used in human application? Is it to, calm the mental state, or what is the purpose of using it?
It's
I think it's anti-inflammatory.
yeah, and
Okay.
it's used in a lot of cancer patients as well for pain relief. It's been shown to affect appetite, so like preventing like cachexia and especially when you're on multiple chemotherapeutic drugs, lose your appetite, have nausea, and things like that. But I think CBD has been shown.
It's a drug. It's Epidiolex. It's also a seizure medication for certain rare diseases.
Yeah, also in the 80s and the 90s, it was used like an anti-diabetic drug. So it has a lot of properties. So just we need to pay more attention to CBD in the next couple of years.
Yeah, the worms don't know what they're missing.
I think they are actually enjoying that.
But they don't really have immune systems though, right? So I think it makes sense that they wouldn't see a benefit from this.
That's a good point.
This is the tough part about worms is like, I mean, immune health is so important for human longevity, completely absent from C. elegans, as far as I understand.
But there are also some like experiments in neurons that actually in specific disease that is called amyotrophic lateral sclerosis, that we can use tetracycline and other type of these drugs that can actually make the lifespan of these neurons longer. They are little experiments and they are not actually relevant in clinical, but they are in the Petri space, it works.
Awesome.
And Benji, I have a question because you delayed the worm fight for a few days and that is because you didn't have the result of the worms because the worm didn't die with any treatment. It was because of that.
No, it was this was completely just like us needing to get the data like QC'd and ingested into our databases, which takes time. And was just taking the devs a little bit longer than we had originally planned for. So no, this was not.
Tell the truth. Tell the truth. There was a Brian Johnson worm, and that motherfucker refused to die.
He fucking refused. He took so many mushrooms that he just like kept going. And the lab was like, we can't end it. I'm sorry.
And I think that the community is thinking the same than me, because I see that now then in the pan side the people are buying doxycycline. So you are postponing this result, no?
Yeah,
Pure speculation.
maybe it's speculation. Maybe doxycycline is being talked about, and Girish is making them super bullish on it.
I hope that you have a good result with this, because Giri say, no, doxycycline is amazing. We will see.
We'll see. That's the whole point.
It's
In
the potential.
15 minutes.
It's all fun and games until the worms are dying. Okay, I think we got our answer here.
Oof.
CBD doesn't work in worms. Maybe in some of the other animals.
Do we have funding for flies?
For CBD?
Yeah.
Yeah, and I think it's ongoing.
Oh, nice.
All right, so doxycycline, we tested 3 different doses. Just getting started over here. We're 4 images in. All the worms seem to be alive. Wait a second. What happened? Oh, it's just spazzing out.
Benji, I'm starting to think you need a new computer.
I am going this weekend to get a new computer. That's for damn sure.
It's been
It's
limping along. We do have the Worm Lab on with us.
Oh,
Ben,
amazing.
welcome.
Hey, can you guys hear me all right?
Sure
Doctor
can.
How's
Ben
everyone
Blue.
doing? You know, I don't know, I probably have told you this joke before, but so my background's in the biology of aging, and I got married last year, and I really should have taken my wife's last name, because then I would have been Dr. Young, the aging doc.
Oh,
But that's a little on the
Wow.
nose. It's pretty cheesy. Yeah.
what? It would have been too
This
So
is
you get to
good.
see some
time.
familiar faces and
There's
Actually, I think that the best devs are married, right?
the best.
Just saying.
Yeah,
I like that.
the ladies know what works. They know.
And
Yeah.
gentlemen,
All right.
Yeah, I was gonna say.
Chris.
What's happening? What's happening over Aura? Any exciting things?
Oh, tons actually. We are getting more and more cool translational results day by day. So we've been really moving forward on some new compounds. And yeah, we're hopefully gonna have some big news soon. And that's about as much as I can say right now. So
Cool.
I'm excited. But churning away, you know, Krister also, you know, I always love to chat about what you've done with the mTOR screen and rapamycin longevity labs, and you know, I think that project is getting pretty close to completion. And then under the hood, I think we're also really churning away and getting close to completing all the studies with that as well. So really excited so that we can work together, share some data down the road.
Yeah. No, but that is a super huge project that Rapamycin Longevity Lab has partnered with Aura Biomedical to screen 601 mTOR modulators. So the largest screening project that has been done. So yeah, super exciting when that result comes out.
Yeah, I'm really looking forward to that. And then other, you know, day-to-day, you know, solid work at Aura is giving Benji high blood pressure as he becomes the most patient man as we've worked to get our systems to play well together. So, you know, the team over at Pub Science has been so generous. You know, we've got a platform we built all internally, and I just want to highlight, you know, it's been really fun working with these guys. So,
Oh,
devs, your tokens are in good hands.
let's go. Love to hear that. And
All right.
Ben, yeah, like we have really learned a lot about your guys' data model. And yeah, definitely. I don't know if there's anyone who understands the data coming out of Aura better than us at this point. We have dissected it literally bit by bit. And yeah, we now have like a set of unit tests of basically all the data coming out of Aura. We can test whether or not it is like quote unquote sound.
Yeah,
With
I'm
in a
really
completely
excited.
automated way. So
Yeah,
we'll share that soon. But yeah,
that
we've
sounds great.
unit
For anyone
tested your
curious,
entire yeah.
I love this. Yeah, one of the things is we had a system that was built for internal development, and then trying to ship it out has been just the biggest headache. And Benji and his team have been so patient, and I want to highlight they've been helpful, helping us build a better system too, to get the data out faster and higher quality even. So
Yeah, it's been awesome. And like there really are a lot of pieces to this puzzle. I mean, there's all of the data, of course, but then there's also, we were talking about this a bit earlier, but the chemistry. The chemistry is also a huge variable. And like we did have to postpone some of the experiments because like there was novel chemistry that resulted in, just like weird crystals and whatnot being formed on the plates that just made the experiments like probably not valid at the concentrations that were being tested. So like a lot of it's in our control, a lot of it is like science, and you're just like pulling the slot machine, and you get out what you get out, and you kind of just have to adapt. But yeah, I mean, like this is what makes doing live science so like interesting is you literally have no idea what you're going to get.
yeah, it's really fun. One of the things that I think, we should really make a whole publication around at some point is, I know, these experiments, we've got, we've seen drugs published in the past at doses that are chemically impossible. Like, you can take a physicist and have them define how well you could get that drug at that concentration, and it's literally impossible, and people have published on it. And so what you see here with kind of Pump Science's and Aura's data is you've got receipts for everything, good or bad, and you'll see, does something actually crash out? Does it cause a weird effect? Does it cause a new behavior in the animals? We're working on getting our regulatory approval for doing scheduled compounds as well.
Let's go.
So that will be. I'm really looking forward to that. There's the old classic meme of the spiders given different, let's say, fun compounds, and they produce different webs. I'm really curious to see what the worms will do.
Well, what does scheduled compounds mean?
I mean, stuff that's illegal.
Okay.
So we have to. My chief scientific officer right now is working with the local FDA branch to get us approved to test stuff in house. This is something
the FDA, that, or is it the
sorry,
DEA?
Not FDA, DEA. Thank you, appreciate that. So we're working with the DEA office to get that approved. We also, one of the things we have looked at, we actually have a pending grant proposal on, is to use the system to find new ways to treat opiate addiction, since you can actually model addiction behaviors in the animals as a function of these drugs. So not only can you do really fun experiments to see what happens and effects on lifespan, but you can also look at, for the drugs that are having adverse effects on, people's lives, what are some of the ways we can find new ways to treat it.
Amazing. And Ben, what is your current capacity now to run experiment in the worms?
Yeah, we run about 100 compounds a week with our current team, and that's relatively modest. I'm hoping, Aura's going, like right now we're doing a little bit of fundraising ourselves, and I'm hoping that some of the lovely venture folks that I'm excited to have join our team are going to push us to doing upwards of 500 compounds a week. is kind of one of the milestones that I've set up. So.
Wow.
No,
And
this
then
is impressive. Impressive.
how many worm bots do you have currently running, and what's the army looking like? How many are like, what's the capability?
Yeah, we've got 9 right now. I would say 3 of them are set aside for prototyping. So we actually, the limiting factor isn't the worm bots, it's the personnel with the time to actually set them up. So, I'm looking forward, I'm working to, try and bring in some more automation on the front end while we've got the back end fully automated.
Is anyone else seeing this or just me?
Oh boy.
Yeah.
Oh
We
boy.
are seeing,
Come on,
we are
baby.
seeing something interesting there. No?
I'm just making sure that everyone else is watching what's happening. But
What's the number to beat?
The number to beat. So this is the median. So it's not quite accurate. And what the number being shown here is the mean. So right now it's going to be close. Because I think the number is like 37.2, but that's median. And this 34 number is mean. But this is trending like crazy. I think this is going to do it.
Oh, man.
Do we see anything
Oh, boy.
on the market cap?
You don't need to ask me twice. Are the people bullish?
Oh, yeah.
Yep, the people seem to be bullish.
Wow.
Oh, yeah.
Very bullish.
Oh boy.
Let's go.
Let's
Yeah.
go.
Oh,
How about
Krister,
it?
you're gonna have to start a farm. You've got so many bulls.
The bull man, yeah.
Yeah.
No
Or the
bears here.
foreman.
Oh yeah, this is gonna do it.
Oh, damn.
Oh, yeah.
We have a new king.
Let's go.
All hail.
Woohoo!
I think we may need like a
Oh.
sound or something.
Oh, wait.
look
A
for a new
sound, you
king.
say? Are you ready?
Go ahead.
That was a gong for you. We had
Okay.
to ring the gong. Did you hear it? Do I need to do it again?
It
I
sounded
think you need
like
to play it
a washing machine or something
Oh,
like that. Yeah.
dang.
How
Okay.
inspiring.
There we
Can
go.
you guys get the rights to the Game of Thrones soundtrack? I think that could, be your coronation.
Ooh.
Be pretty good.
Yeah, so interesting. Dosing is huge with doxycycline as well, right? Because as an antibiotic, it's typically used, at least in the clinic, at higher dosages. But it seems to have this different effects at lower dosages, where it's like I've seen some studies comparing low doses of doxycycline with higher doses, and at lower doses, it's better at inhibiting NF-kappa B, which is a gene that drives inflammatory processes. So really interesting to see how these results spread across the dosages as well, like the differences in lifespan extension. But we're seeing it across the board, it seems, right?
Definitely seeing it across the board.
And
I think that one of them performed best, obviously, but I think it's pretty. They're looking pretty good all around. Oh my god.
Wow.
It's crazy.
That's crazy. All right.
Yeah,
How many concentrations you try?
with
3.
three concentrations.
And they are very different on each other?
Yeah, quite different. The thing that we would have wanted to try also would have been a little bit lower dose. But we had high, medium, and low dose.
And you can rule out this is a effect on the bacteria. This is not.
That's the interesting thing that you point out there, Ethan, because there has been studies done on both lived and killed bacteria, and you see effect on both. But so there is something happening behind. I don't know, Girish, if you know something more about that.
No. I mean, to your point, there in worms there have been studies both with UV killed bacteria as well as live bacteria, and you see a lifespan extension in both conditions. And then and just to like take this a step back, the reason we bring this up is because, or Ethan brought this up, is because if you kill the bacteria, you're basically calorically restricting the worm, and calorie restriction is the most robust longevity enhancing intervention, right? So that's certainly something that could be at play in this specific context, since the bacteria are live. But like I said before, the experiments show that it also shows a lifespan extension in UV killed bacteria. There's also mechanistic studies in mice showing effects separate from calorie restriction. And then finally, like this final point, there's a lot of the long interventions that extend lifespan, even within the intervention testing program, have been sort of surfacing these effects on the gut microbiome, right? So we cannot rule out that many of these interventions, like for instance, metformin, acarbose, rapamycin, are three that it's emerging like that. It's changing the gut microbiome in certain ways. There's an increase in a particular type of bacteria, bifidobacteria, which has anti-inflammatory effects. So our microbes that are in our gut, on our skin, in our mouth, on our everywhere basically, are part of this super organism that make us who we are and help determine our health. So interesting if, doxycycline might be even interacting, especially at lower dosages, rather than killing bacteria, how it may be stressing them out to influence their metabolomics, or the products that they're postbiotics, I guess, the things that they secrete into our bloodstream, and how that may be influencing cognitive outcomes and lifespan itself. So there's a lot to still be discovered here, but certainly many threads to pull on in terms of there's something special about doxycycline.
I think
what a great overview. Sorry, go ahead, Krister.
If you show the graph here, I think this is quite interesting thing, because this is quite common when it comes to many different compounds. That can you scroll down a little bit, Benji? So one theory that I have is that late in life, when it comes to different longevity interventions, you should maybe decrease the dose so that the graph will not end up in the same as the control. I would like to see the whole curve follow in the same way as it is in the beginning. So something is happening in the end there. My guess is that the worms get weaker or something like that, but I don't know. You see this also in mice, paras, right?
Yes. So yeah, you know that I have the theory. I'm very aware of the body temperature, and for instance, compound that decrease body temperature, then they extend lifespan. But the problem is, like, when the animal gets old, they have problem to get warm. And something that we are seeing is that the animal order, they have lower body temperature, and sometimes even you can see that they don't have energy. They can be weaker, that they cannot warm themselves. So to me, yes, when they are getting old, maybe we reduce the dose, or even we get the animal warmer, that more energy or something, we can see more lifespan extension. So it's something that always I'm considering, that to do some intervention at the beginning and some intervention at the end.
Yeah, because that is also something Girish and I have talked about, that personalized medicine is super important. You cannot just use a standard dose for everyone, because it depending on the conditions the person is in, what if they use other interventions on top of the interventions that you want them to use, etc. So yeah, there are many factors to take in consideration here.
And that's a super important point, Chris. I just want to bring up something else that we often do with our patients. I think the traditional, at my day job at Ageless RX, we have 40,000 patients across the US plus that are using, a number of different interventions for the purposes of enhancing longevity. So I think one of the things that makes us unique is that our clinicians, like you brought up a good point that many people take different dosages of a given intervention. It's tailored towards their goals, to what extent we can, towards individual biological and health demographic factors, and towards like bioavailability as well, like how well they're absorbing a particular drug, right? You might have to increase it if they're not absorbing it as well. But the other thing that we kind of incorporate into our protocols is fluid with the point that you brought up, Krister. As the patient's age or as life circumstances change, there might be a case where you're on a higher dose of a drug, and let's take doxycycline for instance. And as you age, as there's changes in the gut microbiome, as there's vulnerabilities in the gut, say it's becoming a bit leakier, say the microbial composition is changing in a way that's not favorable, maybe you lower the dose of doxycycline to like micro doses, for instance, so that you're kind of able to capture some of the anti-inflammatory benefits, maybe some of the cognitive benefits, while being less of a stress on the gut. So this is also super important to take into account in terms of considering the complexity of, it's not just the drug, it's the protocol. And there's a lot that goes into this process. So as we continue to think about how do we translate these results to humans, these are kind of like at the forefront of our mind because, aging is this dynamic process and our longevity protocols should be as well.
Yeah.
I have a question.
I don't know how... The boys are excited.
The boys are all chime in. I was just gonna say that it's such a good point that I think one of the cool things about this project is working in these complex, like we call them simple model systems. Like we know how worms age, we know how flies age, we know how mice age, but really acknowledging that they are complex and looking for things like the curve that we were just looking at, where stuff is, 10, 15% extension of lifespan. That's a relatively moderate effect on aging. And what is going to be the translatability of something that has such an attenuated small response, as opposed to something that we know is hitting a 40 or 50 even percent extension of lifespan? That's an effect that I'm much more confident is going to be translatable and be more applicable to a wider array of patients down the road.
Yeah, great point.
One curious question, Ben. Is it possible to adjust the dose throughout the worm's lifespan?
Yes, it is possible. It's slightly tricky, but it's possible. It wouldn't really work well with our current automated platform, but the manual experiments for that are actually pretty straightforward.
Yeah.
So I have a question for you, Ben. Yeah. So it's possible in the ones to do some intervention at the beginning of life and some intervention at the end, or because it's treated in the place and it's something that you cannot change?
No, we actually we can modify that, and there's, we don't do it regularly, but we have done it for certain interventions. I believe the Benji Krieger, it's the ICAR token.
ICAR. Exactly.
ICAR token is actually going to be piloting out some of those experiments for the Pump Science platform. They're a little bit trickier to do, but it's conceptually pretty straightforward. So we can look at that. Those are going to be starting at, I believe, there'll be a set of them launching at day 1 of adulthood, just like all the normal experiments that we've looked at already that you've seen, and then several that are going to be starting at, I think, day 4 or 5. I'd have to double check our protocols.
But
I think we're testing both. I think continuous and pulse dosing, just to see, because it's a similar it's not a similar mechanism, but it's like a similar question of, is this best delivered chronically, or, are there potential benefits that can be discovered if dosed intermittently versus continuously? I think it's a similar situation to doxy in that way.
I mean, you look at how people use RAPA in the right?
I wanted to ask for a different complexity level even. So for instance, let's say the first 15 days of the life you treat with rapamycin, and then the last week doxycycline or something like
that. Again, that kind of goes back to what Krister was proposing, where if it's moving animals around between different treatments, not just one shift, it's very doable from a manual perspective. It doesn't fit into our automated pipeline super duper well, but it's conceptually possible. It just would require a decent amount of science time. For those of you that don't know, the way that people always used to do worm experiments up until about the last decade, where folks like myself and other groups have tried to automate this process, is every day a poor grad student goes in and takes a little wire pick and pokes each animal to see if they're alive or dead. And then, if you wanted to change the dose, you can take that wire pick and you can carefully move those old animals between a plate containing RAPA and a plate containing doxy. It is doable, and I've seen people do stuff like that. It's just it's a complicated process, and you need someone with a good set of hands. It's kind of like it's basically like doing surgery. To move these 1 millimeter
no
long
kidding.
animals around. Yeah.
Did poking them cause any trauma because they're so small, or?
I know. So it's actually something that. Garish, you were on the CFTP, right?
I was.
Right.
I can.
This is how. Go ahead.
Sorry, no. We might have been talking. No, I could definitely speak to this and say that. Imagine that you're a worm on a plate, and this giant hand comes and pulls you off your 2D realm and just takes you, onto another plate, and you're flying through the air. I mean, it depends on the technician, really, right? And what we did see is that, we usually have sometimes 3 or 4 technicians, depending on how many replicates for a given intervention that we'd be doing. And some worms were living a lot longer than others. And I suspect after, and I managed one of the groups for some time, that, if you look at the worms after a technician transfers them, some of them look a little beaten up afterwards. And it really depends on how their technique and how well they're placing up the worm and placing it. Some of them poke at it, so I think these automated machines completely change the game in terms of removing those factors. It's huge. I mean, there's no understating how much more reliable these experiments became once you remove the human factor. And forget even this, just the handling of the worm, but we suspected, my PI was Monica Driscoll, Ben. I don't know if you had any interactions with her, but she's pretty big in the C. elegans field. But she suspected even the colognes or whatever scents you were having could even be influencing. I mean, kind of a joke, but at the same time, just goes to show how sensitive these creatures are. So yeah, automating it really makes big changes.
The RAPADOCS results are pretty interesting. I mean, first off, hats off for docs. But look, you guys the combo does worse than docs alone or RAP alone. And we just saw the same thing with RAP and SMER28. So maybe either worms, you can't hit them with these hard levers at the same time, or I suspect that's species specific. But if you can't hit these hard levers at the same time, that's going to be bad for longevity. I don't know. What's your hot take? Because this is actually, I think, quite interesting.
I think we see this in some cases that when you combine 2 promising interventions, then it can have a detrimental effect. I don't remember the researcher from Singapore. I think he found that one more time.
Jan Gruber.
Yeah, because I think he found out 1/3 of the combinations have synergistic effect, and another 1/3 cancel the effects out, and then the last 1/3, then you get the detrimental effects. So it's a super tricky word. So,
but the other thing that I'm wondering, like, I'm interested, Ben, on your thoughts here. But like, aside from the molecular, rationale, what do you think about the chemistry itself? We talked about this multiple different times now.
Yep.
But like rapamycin, is it playing friendly with other? Yeah.
So this is where, I think the benefit to these experiments with receipts is really valuable to the field. So what we've found is that RAPA is one of those molecules where there's a ton of C. elegans data published at concentrations that are physically impossible without RAPA crystals growing on the plate. And so some of the published stuff where shows RAPA works at biologically relevant doses in C. elegans, it just doesn't fly. And so the reality is, if you want to do a good experiment with RAPA in worms, you're hitting them at relatively low dose. And so that's not meant to be a slight on RAPA. RAPA's the gold standard for longevity interventions that are clinically approved right now. What that means is that RAPA is just the starting point. And so looking outwards from it, as we think about, okay, we know RAPA, we know mTOR, what can we take from this and learn to develop our next generation of longevity therapeutics? And that's where, the work that Christer's doing, while rapamycin longevity labs is what it's called, it's not stopping with rapamycin. And so I still think this is relevant data. And, we know from patient experiences around RAPA that dosing and the chemistry is really important to having a beneficial effect. So this is just kind of underscoring the point that it's a good molecule, but it can be hard to use. And so, I think that's what I take away from these results. Not that it isn't completely worthwhile.
Yeah. Can I just interrupt a little bit here, because now we're doing the RAPADOCS experiments, and we have not talked about that token. I think it's important also to lift what this is. Can you talk about that, Giric? It's 2 FDA-approved drugs that we combined, and why is that interesting? And
do we want to start with the longevity perspective?
Yeah, decide you.
Okay, decide on my part. Yeah, so as we mentioned before, there really aren't any magic bullets as far as we could tell, and doesn't seem to be one major regulator of the biological aging process that we can find and target. Rather, aging seems to be pushed forth by this network of interactions, this molecular circuitry that kind of becomes unbalanced, driving multiple different hallmarks of aging to accumulate multiple different types of cellular dysfunction. So, it's a kind of a tall order to expect one intervention to rule them all, to be able to kind of like address everything that can and may go wrong with the aging process. I think a really good example of this is some work done by Jay Olshansky, who's a really great figure in the longevity field. But he kind of like dissected some epidemiological studies and looked at, if we eliminate all cancers, right? The number 2 cause of death, we eliminated all of them, how much would we be able to extend lifespan? And the answer was 3 years. Okay. If you were to eliminate all cancer and all heart disease, you get maybe a 7-year extension of lifespan. I mean, wildly under what you would expect when you think about
the reason that paper by that paper by Jay Olshansky is the reason I left the oncology space. I was working in cancer diagnostics. I read that paper and I left.
It's absolutely wild. It's an absolutely wild result. When I first read it as well, it like knocked me off. And the reason for this is because you're only as strong as your weakest link. Right? Basically, it boils down to where if cancer doesn't get you, some infectious disease will get you because you've grown frail to the point of being susceptible to it, or Alzheimer's disease will occur, or a number of other diseases that can occur. And that's because all our organs are aging, at different rates due to different types of hallmarks that are accumulating. So swinging back to RAPADOCS. There are two distinct interventions that are, we've chosen to strategically combine because they act on different molecular drivers of the biological aging process. So we're kind of broadening our scope and coverage of the networks that we're, targeting, so that we can theoretically get larger extensions in lifespan and longevity. And, to Ethan's point about if combinatorials don't work, it's an issue in that, we kind of need combinatorials in order to, more fully and comprehensively address this network that drives aging. And I think, again, to Ben's point as well, there might be several other factors that are coming into play when we're running these experiments that may interfere with, kind of getting at the truth of how these compounds may synergize together. So that's like kind of the longevity perspective on rapamycin and doxycycline. Rapamycin is a known mTOR inhibitor, activates autophagy, is potent anti-inflammatory. Doxycycline seems to cause this hormetic effect on mitochondria in a separate sort of sense, lower inflammation by inhibiting NF-kappa B. So we're trying to increase our coverage of the different flavors of damage and dysfunction that can accumulate and drive aging. And hopefully we can get the right combination with the right concentrations at the right timing to make some really meaningful improvements in the lifespan.
It's like OMIDOCS is back to square one. So the king of the pill and the former king of the pill don't play well together.
Yeah, let's.
So interesting. Kings don't get along. You can only have one king per kingdom.
What result did we have on RAPADOCS?
We had 25%.
25, okay. And the interesting thing also, if we look at the RAPADOCS, rapamycin plus doxycycline, and doxycycline, and then we also have partnered up with Etena Labs, who is the dev team for rapamycin. Together, if we look at these 3 tokens, all of them are FDA approved, which makes them a fast path to market. So the thing we have started a startup quite recently around this, and we are entering a multi-billion market with these tokens. So the thing we are going to do at the next step here is to enter the hair health market. And with that, I mean these 3 interventions, we will look if they can reduce, for example, gray hair, hair loss, and things like that, which are huge age indications when we get older. Almost all people get these. And if we can, for example, slow down and also in some cases, increase hair growth and things like that, that would be a huge thing. So that is something which we will start next year with research. We have also looked at the distribution, manufacturing, and things like that. So big plans on those tokens.
Oh, it's good to hear that we have coined a company taking off, and it's not just Raptor. We have Raptor Co. coming as well. So this is great that we have this this friendly competition here. But like in the science here, it's like, what does this tell us? Like, does this mean like how much value does the worm ultimately have if we know we're going to have to hit multiple levers? But if the worm is too simple, or for some reasons have to do with it being a worm, it's just not the appropriate model to now take the kings of the pill and see if they can unite the kingdoms, because, we could get stuck in a bunch of worm-specific stuff. So I still think there's utility to worms, but if you have to thread the needle with the dose because of solubility, bioavailability, and all these other issues, plus worm biology is fighting against you, at what point it's like, fuck the worm. Like, the worm may be useful to identify the individual levers, but maybe it's not the right model to actually do the combinations. Or are we just over-interpreting?
Yo, fuck the worm. That's a hot take.
You know, so here's the thing. I think that take is couched in good logic, but I wouldn't take it to that extreme. I think the challenge is that you'll find that worm biologists will try and defend the worm on a hill in ways that they shouldn't. And the reality is, a worm is not a human. There's going to be big translational gaps, just like what you brought up. But even then, we think about mice as our model. Big translational gaps there. They have telomerase constitutively active throughout their life. People talk about the dogs as a model for longevity. And the reality is, people talk about a little bit of chocolate each day having, an antioxidant effect and being good for you. That would kill my dog. So no model system is perfect. And it's so important to acknowledge that and say, pardon my French, fuck that model system in the right context. And so this is where I think, doing primary screening tells us a lot. But we also know, RAPA's got a lot of complications in the clinic. And I come out of a big history of liking the story of RAPA and mTOR, but you have to get the dose exactly right. You got to get the dosing periodicity exactly right. And so we see, the metaphor of those complicated, druggable features weirdly translate into our worm model, right? So I think the worm as a model still has yet to get a major point on a scoreboard with a drug starting from a worm and going outwards into the clinic. And I'm really excited that either what we're doing at Aura is going to be the first point on the scoreboard, or maybe even, what Krister's been doing with OMIPAL might be the first point on the scoreboard for that. And either way, it's really exciting.
Yeah, absolutely. And I want to, again, bring us back around to, I think, just let it sink in about the flexibility that this model provides us at Pump Science, right? With rapamycin and doxycycline, the combination, right? Doxycycline alone, right now, the new king of the pill. With RAPADOCS, it didn't quite hit that mark. But one of the interesting paths that we decided to go as we started looking at individual pieces of data with rapamycin and doxycycline is that rapamycin, seems to be reducing cellular senescence of hair follicle cells. Doxycycline seems to be used to treat alopecia, which is a form of inflammation at the scalp. So it can address different hallmarks of hair aging. So now we're going to proceed down the path of, rather than, kind of going down the, default path, or what people can interpret as a default path of checking lifespan in worms, flies, and mice, we're going to hyper focus on RAPADOCS and its utility and potential within this, very real, very tangible, multi-billion-dollar market, which is hair health span, with these two promising compounds that are FDA approved, that we can really kind of deploy to the public if they continue to show beneficial effects in the different experiments we're planning. And I didn't know, I wasn't sure how deep to run with this in terms of what we're actually planning on doing. But let's just say if it works on me, I think we have a multi-billion-dollar compound in our hand.
Yeah, cool.
Now I was going to say, when you guys made a comment about gray hair, I was like, oh my God, are my systems failing? I have some. Is this like a red herring or a gray herring? I'm a little bit stressed.
Cool. Now we also have the OMIDOCS token, and it looks better than
looks
RAPADOCS.
Good now,
yeah. And OMIPAL, if we look at that compound, Rapamycin Longevity Lab discovered that compound last year that it had life-extending properties, really promising life-extending properties in worms. I think it was more than double the effect that has been seen in when it comes to rapamycin. So that is currently the lab's leading compound, and we have had initial discussions with big pharma around taking omipalazib to the next level. And the thing they have said is that they want us to create a strong data set around the omipalazib. It doesn't need to be omipalazib alone. It can be a combination. So that is something we are currently exploring here on Pump Science. And all the data from the different tokens will share the exit or the returns if we do a big exit and big pharma wants to collaborate with us. So, yeah, things from the initial discussions we have had, they felt super interested, and yeah, let's just deliver great data to them. And we have soon warm data on OMIDOCS. We have warm data on OMIPAL. We have started fly experiments on omipalazib and also mice experiments on omipalazib. So yeah, lots of things are going to happen next year. So we have 2 really promising paths for our tokens.
Let's go.
Really cool.
Maybe now's a good time to remind everyone that everything you hear here is not financial advice.
Yeah,
But,
definitely. And
regardless, I'm bullish as fuck.
The thing here is also that anything we say here is not medical or financial advice. It's for educational purposes only.
Yep.
So yeah.
Speaking of medical advice, Girish, I'm actually thinking now about what the optimal route of administration of doxycycline might be. Is it possible? And I don't know how, I don't understand the pharmacokinetics or dynamics of dox, but could you get around a lot of the GI microbiome issues if you took it sublingual? And is that even a route of administration that works with doxy?
That's a super interesting question. And I don't know. I mean, absolutely. I'd suspect that if we're able to get significant absorption sublingually, which would, kind of be dependent on its molecular weight and chemical properties, something definitely to look into. But, the other, yeah, of course, sublingually, topically, I mean, depending on the delivery modality, we may be able to get more targeted administration. At Ageless, Ageless RX, one thing that we're noticing is, for instance, with our NAD, we have nasal sprays, we have injections, and we even tried sublingual GLP-1s. And what we were seeing is that patients were reporting different benefits based on the delivery modality. So I wonder if we had sublingual doxycycline, are we able to see better cognitive effects while avoiding the GI effects? Same thing with topical administration and with hair health. So there's definitely several possibilities that we are exploring. Interesting that you put sublingual on the map, though. That's something that I hadn't thought of before, but something that we'll definitely look into.
Yeah, we should definitely try the topical. I think the topical is fascinating for hair, like reversal of hair senescence. And I mean, just for the record, I don't know how well you can see. I got a massive bald patch on my beard, super randomly, and I've gotten them before. It's alopecia areata, which is it's just basically like an immune reaction to your hair follicles. And I didn't try doxycycline the first time. I tried a topical steroid, and it took them away completely. But every time I get stressed, basically every time the price of Bitcoin goes down enough, I'll get a new one.
Did it just poof out at the moment? Did it just fall out?
Yeah, no, it's really scary actually. Just like all of a sudden, like I'll be shaving and then there's just like nothing there, and I'm like, I don't think I shaved that spot.
Whoa.
Whoa.
Yeah, so it happens frequently. And yeah, no, it's been topical steroids that has worked on it in the past. So there's clearly something immune there.
Yeah.
Doxycycline, as we know, is like it goes after bacteria or it has some sort of immune effect. So super curious to see whether that works for head hair loss, like basically alopecia, androgenetic alopecia. But yeah, super excited about that use case. But like I think that these different routes of administration will be super interesting because, like, especially with anything that works on the immune system or works on bacteria, obviously if you take that orally, that will have a very different effect because you have all these healthy bacteria that you want to keep in your gut. And so taking anything, that affects the immune system or the microbiome of your GI tract is, probably going to have some bad side effects. Another thing I've been thinking about a lot is these orally administered GLP-1s, like you were talking about, sublingual. And obviously people before were doing and have been doing a subcutaneous, basically injected into their body fat. But everyone obviously wants to go to oral GLP-1s. The only problem is you have a ton of the GLP-1 receptor in your GI tract.
Yep.
And so there's bound to be unforeseen side effects that come with, orally administered semaglutide, these peptides. So I'm super interested to see, like, when they come out with these oral GLP-1s, will they be the peptides? Will they be small molecules? Anyway, we'll see what happens.
They have the Ribelsis, I think it is one of the oral GLP-1s. It seems to show similar effects in terms of lowering blood sugar, hemoglobin A1C, and appetite suppression. But no, I'm sorry. It seems to show similar side effects, but the injectables are more potent. And the other thing that's interesting is I've seen some like case studies in which, GLP-1s are interesting in that they'll kind of interface with your neurobiology in an interesting way. Dopaminergic neurons that produce dopamine, and regions in the hypothalamus that like tamp down on cravings and reward signaling. So you see interesting phenomena like individuals being able to cut down on alcohol consumption and cigarettes smoked per day. And the oral versions, don't seem to be as effective at that. So to your point, what's going on at the gut? How much of the GLP-1s being sopped up in the GI and not as much interfacing with the brain or crossing the blood-brain barrier are all super interesting points.
Oh, comment from the audience. Oh, wait, wrong one. Stop shilling GLP-1s. This is big pharma propaganda.
From Dr. Ponzi himself. Get off the stream, bro. We didn't want you here anyway.
I was listening to Dave Ricks's. He was like on can't remember what the podcast was, but he was talking about like the caloric intake of like the average American. I think it was like 3,500 calories.
Yeah, he was on with the Collison brothers on their podcast, I guess. And yeah, 3,700 calories, average American caloric intake. And look, 3,700 calories isn't that crazy if you're a triathlete. But if you're just a normal, like relatively sedentary person, it explains a lot.
Did he say though on GLP-1s it was like 800? I thought he said immediately after that, or maybe I think it was 800. But it was super interesting. I was like, whoa, I didn't realize the deficit was like that much. It's crazy.
Yeah.
To preserve
that's getting close to like some
Sorry.
That's getting close to some like Walter Longo's prescriptive diets around longevity benefits and even anti-cancer treatments, actually.
Yeah. I was gonna say to preserve Dr. Ponzi's sanity. I wanted to. What did we see with OMIPAL and docs? Where do we end up with there?
We ended up with 50% lifespan extension. Pretty solid.
Yeah.
But when you're doing 80% with doxycycline alone, it's kind of hard to beat. I don't know if we'll ever beat that. Will we ever beat that?
Was it 80% doxycycline alone?
Yes, it was 80% doxycycline alone.
Whoa.
New king of the
God.
Yeah, so time to start chugging doxycycline. Not medical
Wow.
advice. Not medical advice.
Okay.
But I might be doing it myself. So
Yeah.
So what is the take-home message of today?
take-home message of today is doxycycline is the new king of the pill. We really have to understand, like, how. Like, is that going to translate? Is that because it's just killing the bacteria and causing caloric restriction? I think you can make the argument that it's not because, you know, arguably omipalsib and rapamycin are doing this, or no, they're not.
No, that might have been a concern for methylene blue, but no, I mean, look, you guys said there was 90% in other studies. You hit 80, so like it's reproducible. It's nearly doubling. Like that's real biology. So that's super cool. I mean, obviously right now, but like, you know, in fairness, like your token hasn't pumped. I mean, it pumped a little, but it's still 38K. You know what I mean? Like if people thought this was the next hair loss blockbuster, I think this would have been ripping. So I think that's an important lesson for all of us. And so for Raptor too, no one gave a shit that the worm data wasn't good because the price is exactly the same. So I think, you know, that's this one little lesson. But ultimately, like, yeah, I think that what's next is it's ground game. It's who's going to execute. Like all these molecules are open source. They're all available. You know, you can't have patent protection on the molecule. It's all about execution in the teams now.
Yep.
So I'm glad to see RLL's making a company. You know, hopefully we inspired you guys. Probably going to do it anyway, but good to see you're doing it. Probably HairDAO is not going to like the competition, but you know, obviously go to a big market. You know, we're hoping with Raptor to go to performance if we can. You know, I think that's smart. So yeah, it's super. You guys know how to pick the winners. So hats off to you guys. But at the end of the day, you still have to put this into people and just do it responsibly. And that's all about execution. And many teams die with execution. So I'm excited to be competing with you guys, and congrats for your performance today.
Yeah, thank you. And execution is super important. So that is something we push all the time in labs. So I think Benji said also one great thing about the execution, that execution is more important than perfection. I think that is a very good thing to keep in mind, because it's very easy to fall in the trap and try to create a perfect strategy or something like that, and then you overthink things and don't execute. So it's better to execute and pivot throughout the way, because there you see the results. And Rapamycin Longevity Lab, we will execute so much, so you will see us.
We know you will. Trust me. But I got to give credit where credit's due. It wasn't my quote. It's Thomas Edison, which is it's what 1% inspiration, 99% perspiration.
Yeah. I want to also highlight
10% luck, 15% skill.
20% concentrated power of will, 5% pleasure, 50% pain, and 100% reason to remember the name.
We don't need AI, we got rappers.
Yeah, I just want to take one small moment here also to highlight our Monday launch of T-Rex. Partial reprogramming, which is a super exciting intervention, which is about reversing aging instead of which many interventions look at. It's to slow aging. So with partial reprogramming, that is a super interesting technology, because there you start to trigger like a rewind button in the cell. And when you press that rewind button, then you can reverse the old cell to a young cell. And that is super exciting thing. Paras, you have research quite much around partial reprogramming. Maybe you can say some words about that.
Now, this technology, it was discovered a long time ago, and it was a Nobel Prize when the reprogramming came up, that showing that the cell can go to the differentiate cell to a stem cell, and in this process later was demonstrated that rejuvenate. So to me, it's a very interesting, but I mean, we are in the first step of the reprogramming. Many money was coming to that. For example, Altos Labs, 3,000 millions, new limits, as few companies raise a lot of money doing reprogramming, more genetic than chemical. Here we are doing chemical. And to me, I think that is a very interesting thing to explore. There are many experiments that we can do, but the first one is to start with the worms, with the flies. Even late in life, I would like to see this, that treating the animal late in life, we can rejuvenate and extend lifespan. This could be super interesting to see.
Yeah, super exciting. So partial reprogramming token, that is like our path when it comes to radical life extension. That I think is the closest we can come from a microscopic level to create radical life extending cells. So and now we are going to see if we can translate that to humans.
Amazing.
I was going to say, Benji, what were you just looking at?
Oh my God, it's not pretty out there, guys. It's not pretty. Sol's absolutely tanking, 145, and Bitcoin's at 98, and they're just an absolute free fall. And so, but the story goes on, the show goes on. Beth isn't going anywhere, so neither are we. But hot damn.
Well, I was going to say, I mean, I know Ethan made a comment about like some of the tokens not having like gigapumps. So when you look at the context of the broader market, I mean, it is super impressive that there's this like, there's not the same like resistance. So I don't know. I think there is a different lesson in there than maybe the one that would be the takeaway if you don't look at like the overall market. So hard to say, but yeah, I mean, prices are definitely on the broader market in a bit of a free fall at the moment.
That's exactly why I brought this up, to make the exact same point. I think it's very difficult to look at price action relative to data when you have this going on.
Yeah.
But when things go down, then prices are going down, things are undervalued, then it's also a good time for investors to go in, because things will go in the other direction someday. But of course, this is not financial advice, but
medical and financial advice brought to you by Pump.Science. We should probably get off before we get ourselves in trouble.
Yeah, cool.
The science will go on, though. I think that's the cool thing, the cool takeaway here. The fly studies are still underway. We have mouse studies still underway. So there, even in a down market, there is still science being done, bodies of evidence being built for these compounds, which is so cool. So even if the market plays out, so will the science. So we'll see. We'll be back with more.
Bodies are hitting the floor in more ways than one.
We're still dying. So there's still a shit ton of work to do.
Oh yeah, cool. Thanks, team.
Okay, tomorrow we see it at doxycycline King taking the throne down. Yeah.
Huge congrats on King of the Pill, guys.
Yeah, thank you.
Thanks, everybody. From one head to the same head.
Yeah, wonderful. Yeah, take care now. Bye.
Thank you.